Okay, dear students, let's continue again. So what follows is the following one, question number 3. It says find the exact numerical value of cosine hyperbolic minus ln 3 plus sine hyperbolic ln 2. Choices are given to you: 11 over 6, 13 over 9, 5 over 4, 29 over 12. So here what you need to do is you have to recall the definition for cos hyperbolic x and sine hyperbolic x. The next is a matter of plugging these two values, minus ln 3 and ln 2 respectively. So here is the solution. So as you know, sine hyperbolic x is a power of x minus x over 2. And cos hyperbolic x is given by is a power of x plus is a power of minus x over 2. So when you directly substitute this minus ln 3 in place of x of this cosine hyperbolic expression, you see, you can obtain this one. E is a power of, this is negative ln 3, so you directly put minus ln 3 here because it says x, plus e is a power of, look, this is a negative x, so the one you're having would have, you see, negative in front, so negative turns to be positive, so this turns to be ln 3. Then this is divided by what? 2. As you know from your logarithmic expression, e is a power of minus ln 3 is the same as e is a power of ln 3 is a power of minus 1, guys. So 3 is a power of minus 1. Look, this minus 1 was written somewhere over here, but using logarithm property, this minus 1 can come in front and be written in front of ln. But for the timing, let's take this minus back. Look, minus 1 is going to be here, so it will be 1 over 3. You see, 3 is a power of minus 1 is 1 over 3, so e is a power of ln 1 over 3 is 1 over 3, as you see, and e is a power of ln 3 is 3. Is a power of ln 3 is 3 because ln is logarithm to the base e, so this the number you are having here comes as it is, then this has to be divided by 2. So as you are doing this, 3 with 3 makes 9, 9 with 1, 10, 10 over 6, which actually is 5 over 3. So that is all about the first one, cos hyperbolic of negative ln 3. Do the same for sine hyperbolic of ln 2. Look here, sine hyperbolic of ln 2 is nothing but it is a matter of, you see, substituting ln 2 in place of x, where? In this expression, you see, this expression. So you're having here ln 2 in place of x, so this is a power of, what is x? Ln 2, it's used here. So ln 2 minus e is a power of, it says negative x, so minus ln 2 divided by 2. Look, as I tried to explain earlier, this is 2, because ln 2 is logarithm 2 to the base e. So whenever you have logarithm of a certain number to the base e, you see under exponent of e, the number comes as it is. So 2 comes directly, as you see. Then the minus follows directly, and then this minus can go up, and this can turn to be 1 over 2, and e is a power of ln 1 over 2 is 1 over 2. So this 2 comes as it is. So this makes 2 times 2, 4, minus 1, 3, 3 over 2 times 2, 4, 3 over 4. So here we obtain these two values. You see, the thing that we are asked here is to add these two together. Okay, it says here, add them. So what we need to do is we have to add these two, 5 over 3 plus 3 over 4. So as you see, 5 over 3 plus 3 over 4 makes, students, 29 over 12. So where is 29 over 12 in our multiple choices? It is located here in D. And because of this, the answer is, okay, make it D, guys, please. Make this to be D. So the answer will be D, 29 over what? 12. See, 29 over 12. Correct that by that, please. And next from this, what follows is the next one, which actually is the fourth one. It says for propositions P, Q, and R, which compound proposition is not a tautology. Basically, students, you have to know what a tautology is. A tautology, as you know, is a compound proposition having truth value true for whatever truth value assigned for each proposition. Okay, so you are given these choices A, B, C, D. So we are going to select the one which is not, see, a tautology one. So the idea goes like this. As you studied in our class, as we studied in our classroom, we said that P implies Q is equivalent to negation P or Q. These can be easily checked or proved using truth table. Prepare truth table for P implies Q. And again, for minus P or Q. Believe me, you will obtain identical output. You can even verify this by using what? Truth table. You can do it directly. It's a matter of preparing a table with 4 rows. So if these two are equivalent, look, if these two are equivalent, look, the question says P implies Q, negation P or Q. If two compound propositions are equivalent, then the by implication of these two will be always true. Because if this is false, this is again false. And we know that the by implication of false and false makes true. False by implies false makes true. What would happen if this is true? No problem. If this is true again and this one true, true by implies true is true. Because according to the by implication principle, you see, compound proposition joined by using by implication gets what? True if what happens? If the components are having identical truth value. And when we come to B, what follows is, you see, when we come to B, take the contrapositive of R implies negation Q, students. What is the contrapositive of R implies negation Q? The contrapositive of R implies negation Q is Q implies negation R. And we knew that the contrapositive of R implies negation Q, which actually is Q implies negation R, is equivalent to the original conditional statement. That is to say, these two are equivalent. These two are equivalent. So equivalent propositions are now, look, combined by using implication. This shows that if this is true, again this is true. True implies true makes true. If this is false, again this is also false. So this shows you that false implies false is again true. So for whatever truth value you may assign for Q and R, this is again always what? True. This is always true, students. So here it is stated over here. Everything is true. And coming to D, just skipping C because there in C we do have a case where we can't have tautology. But when you come to D, look, it says negation of R implies negation P. This basically is equivalent to have negation as it is, but using the first one, you look at this concept. P implies Q is going to be negation P or Q. Look, the hypothesis is negated and the conclusion is taken as it is. And between we do have or. Similarly, the hypothesis is negated as you see. Then in between we have or. Then negation P is taken as it is. Now remember De Morgan's law. De Morgan's law says that this is equivalent to R and P. R and P, students. Because negation makes R, and negation turns this to end. And negation makes what? P. So look, student, now R and P is going to come. Look what has been written here. P and R is the same as R and P. Yeah, conjunction can have commutative property. So these two are again identical. So whenever you have equivalent propositions being combined by implication, the truth value is what? Always true, which actually is a tautology as I explained in A. So also we have always what? True case. But as you are coming to C, look, if you assign P to be true and Q to be true again, you will obtain this to be what? False. Just I took P true and Q true arbitrarily. One can also take another, no problem. So long as you are able to obtain C to be false, you can apply that. But as you are taking P to be true and Q to be true, what will happen is this one. Look, the negation of Q implies negation P, the one you are having to the left side. This is the negation of T implies negation of T, which actually is basically false. You see, this is false and this is false again. False implies false is true. Due to the presence of negation outside, this turns to be false. So look, this is obtained to be false. We have assigned that P and Q are true. True implies true is true. False by implies true is going to come, which basically is false, right? So both are true. We have T here, but as you are having this, false by implies true, which actually false can come. So this shows you that except, you see the third one, that is C, the rest are, you see, yielding always truth value T. They are tautology, we can say. So the answer for this is going to be C, okay? I hope you have understood the idea in a better way. Now comes another one, so we are going to go to the next one.